All right, we're going to look at page 65 through 67 in your guided workbook. So on page 65, you'll see this chart. So in this chart, you'll notice that here at the top it says U.S. population. Here it says number of divorces that occurred in that year, meaning 1900 or 1910. Number of marriages that occurred in that year. The total number of marriages in the population. And then these last numbers are basically scaled numbers. So this says divorces in the year per 1,000 in the population. So it's taking the number of divorces and comparing it to the population, but it's scaling the population at 1,000. And then this one is saying marriages in that year per 1,000 in the population. And this is saying divorces in per 100 marriages. So it's comparing divorces to marriages. Sorry, I said this wrong. It's comparing divorces to marriages, and it's scaling marriages at 100. And then this one is saying divorces per 1,000 marriages. So it's taking the divorces and comparing it to the marriages, but it's scaling it at 1,000. So they want you to take the information from 2004, which is 3.8, 7.8, 48.7, and 18.3, and basically write a sentence. So your sentence here would be that there are 3.8 divorces per 1,000 people in the population in the year 2004. The 7.8 would be there are 7.8 marriages out of 1,000 people in the population. This one says there are 48.7 divorces for every 100 marriages that year. And this would say that there are 18.3 divorces per 1,000 marriages in the total population. So notice here, like for example, they're comparing divorces and marriages in the total population. And then this one, they're comparing divorces and marriages that year. So there's a little bit of a difference there. So which one of these do you think best represents the divorce rates? We're looking at question number 2, and explain your answer. So in my opinion, comparing the divorces to the population seems arbitrary, since only married people can actually get divorced. So you really need to compare divorces to marriages. So it makes more sense to compare one of these last two columns, either divorces per 100 marriages that year or divorces per 1,000 marriages in the population. Okay? So the next question is, which one is a better total? And so here it says, which rate seems to support the idea that half of all marriages end in divorce? So there's two possibilities here. The divorce rate per 1,000 population is roughly half of the marriages per 1,000 since 1980. So what we're doing here is we're talking about the divorce rate per 1,000 population. So that would be this number here. Okay, so what they're saying here is the divorce rate per 1,000 in the population is 7.8 in the year 2004. And in 1980, it was right here, it was 10.8 per 1,000 in the population. So, and then back here in 1900, it was 9 in the population. So the divorce rate per 1,000 population is roughly half of the marriage rate per 1,000 population since 1980. So we're comparing the divorce rate in 1980, which is 5.3, and the marriage rate in 1980, which is 10.8, and they're half of each other. The other thing you can compare is the divorce rate per 100 marriages. That's roughly 50%. So notice here in 1980, the divorce rate per 100 is slowly increasing. So notice it's 49%, 48%, 49%, 48%, and it was like in the 25, 17, 16, 13% back here. So in 1980, there appeared to be an increase in the number of divorces that were occurring in marriages. Okay, so does the conclusion that roughly half of all marriages end in divorce logically follow from this? And no, it doesn't. I mean, you would have to go back and look at a lot of information. You would look at you know, how many marriages were there. You wouldn't want to compare marriages and divorces in the same year, because usually if somebody gets married, they don't get divorced in the same year. So this doesn't necessarily tell us that half of all marriages are ending in divorce. So then we have this scatter plot with the data, and this is what it looks like in the 1900s. And you know, you see this fairly consistent. Here's that trend line going through here. And then here in 1980, we have this obvious jump to this higher percentage of divorces. And then it's declining a little bit and getting a little bit back into the normal range in the 2000 area. So the question could be, why did the divorce rate increase in 1980? So that's what you have to discuss. You have to think about that for yourself. But here are some possibilities. So there could have actually been more divorces if the marriage rate of the population was increasing, even if the divorce rate was falling. Marriage rates were also falling. Living together, having babies out of wedlock became more socially acceptable during this time period. So maybe that's why couples were less likely to get divorced, because they didn't get married to begin with. So that leaves the pool of people that could have gotten divorced to decrease. And so that could explain why over time the divorce rate starts to go down a little bit, because this is talking about the divorces per population. So it does start to go down a little bit, but again, that could be because fewer people were getting married and not staying together. Okay, so we have a couple more questions. If you knew what the number of new marriages has been declining since 1980, maybe it was because young couples chose to cohabitate, does that change your answer? So that means that there are fewer marriages in the denominator, so that means your rate would go up. But maybe the ones that are not getting married are the ones who have divorced are divorced anyway, resulting in a lower divorce rate. So there's a lot of things to consider. You have to sort of make these judgment calls on your own. There's not necessarily one set answer for these. Okay, so interpret the slope of the line as a rate. So here we have, back in our trend line, you'll notice that this number right here is our slope. So that tells us our rate of change for marriages. So what does that tell us? It says the divorce rate per 1,000 marriages total in the population is increasing by 0.1714 divorces per year. So that's what that slope means in this problem. So then we have another step. It says, what if I picked two of the points in the graph? So I picked 0, 22.7, and 24, 18.3. So X is the years since 1980. So here we go again. So years since 1980. So that means this would be year 0. This would be year 10. This would be year 20. And this would be year 24. Okay, so years since 1980. So when I'm talking about the values of 0, 22.7, I'm looking at the 0 and the 22.7. And the other value I'm looking at is 24, 18.3. So I'm looking at the 24 and 18.3. And we're talking about divorces per thousand. So I'm going to set up my slope formula. Remember, slope is y2 minus y1 over x2 minus x1. Okay, so this is my x1, y1, x2, y2. And I do my calculations and I get negative 0.1833. Okay, and then this is my y-intercept because it's the one with 0. So I can use that value in here for my y-intercept, and I have this problem. So what this is saying is the negative 0.1833 means that since 1980, the rate of divorces is decreasing by 0.1833 per 1,000 marriages. So that's what the negative means. It's that it's decreasing instead of increasing. So if I want to predict what would it be in 2020, that means in 2020, X would be 40 because it's 40 years after 1980. So I'm going to substitute 40 in for X for this equation, and I end up with 15.4. So that tells me the divorce rate in 2020 is predicted to be about 15.4 divorces per 1,000 marriages in the total population. Hope this helps.